Welcome back, everybody. This is part 2 of section 6.1. All right, and today we're going to focus on our measures of variability. Part 1 focused on measures of central tendency, mean, median, and mode. Today we're going to focus on measures of variability, which is standard deviation, variance, and range. All right, so let's start with what is measure of variability. Measure of variability measures the spread of the data. All right, so the most basic measure of the spread of your data is the range. All right, and the range, you just take the highest value and subtract it from the lowest value. And that's your range. So let's do a very quick basic example. All right, so if we have the salaries for the staff of XYZ Manufacturing. All right, and let's say the owner, he makes the most, he makes $100,000. The manager, let's say he makes 40 grand. The sales rep, he makes $30,000. And let's say there are workers. Some make 25,000, 15,000, and 18,000. So if you're asked to find the range, basically what you would do is you would just take the owner at $100,000 and subtract the lowest, which would be the worker at $15,000, and that would equal a range of 85. Hang on. $1,000. Now let's make that a little bit better. $85,000. All right. And the range is especially large due to the fact that the owner's salary was included. If you excluded the owner's salary, the range of salaries would be much, much smaller. All right. So range is not necessarily always the best indicator of variability, because if you have one salary, the owner, that is much larger than the rest, the range could not necessarily tell you the whole truth. All right. So a more realistic measure of variability is either the variance or the standard deviation. And we're going to use standard deviation an awful lot throughout this semester. Variance, not as much, but what you're going to see is that one works off the other. All right, so let's start with the formulas that you're going to need. All right, so population variance. All right, is denoted by, this is a Greek letter sigma squared. That's a lowercase sigma, because we know that that's an uppercase sigma. That means sum of. Now you remember mu, right? That's our population mean. So it's our x value minus mu, right, squared, all over our number of values. All right, and our population standard deviation. I'm just going to use SD as an abbreviation for standard deviation, just due to lack of space. But again, we can use sigma, right? Now notice variance, sigma squared. Standard deviation is just plain sigma. So I can make the formula for our standard deviation quite easy. It's just the square root of our variance. Very easy to remember. And both of these formulas will be on your formula sheet. All right, so let's just jump right in and do a very quick example to kind of outline what we mean by the spread of our data. All right, so we're going to find the population variance and standard deviation. All right, for the data brand A paint. All right, and so the data is the number of months brand A will be good before repainting. All right, and so we collected data. We got 10 months, 60 months, 50 months, 30 months, 40, and 20 months. All right, again, I do believe in organization. One of the biggest problems that I always had with things like standard deviation, variance, those kind of things was not because the math was hard. It was because it was hard keeping track of where I was. So again, I'm going to use a chart. I'm going to months. And it could be anything that your data is. I'm going to have your population mean. And then I want to start figuring out some of the values in the formula. So in our formula, I had my data point minus my mean. And then I had my data point minus my mean squared. All right, so let's fill in our data points. 10, 60, 50, 30, 40. I'm going to scroll up a little bit. And 20. All right. So the first thing I'm going to do is I'm going to figure out the mean. All right. So why don't you pause the video for just a second, take your data points and figure out your population mean, and we'll talk about the answer on the back end. All right. So hopefully you calculated the population mean. I got a mean of 35. So I'm just going to put 35 in each one of these boxes because the mean is not going to change. It's the same based on our data. But what this allows me to do is just read straight across the chart. Now I want my data point minus my mean. So 10 minus 35 is negative 25. 60 minus 35 is positive 25. 50 minus 35 is 15. 30 minus 35 is negative 5. 40 minus 35 is positive 5. And 20 minus 35 is not positive 15, but negative 15. All right, one thing we notice is that if we just add up our x minus mu, we're going to wind up with 0. So we can't let our negatives and positives cancel everything out. That's why we square it. So if I square negative 25, I get 625. 625. 15 squared, I get 225. 25, 25. Oop, let me just scroll up a little bit to 25. All right, so I have how many data points? 1, 2, 3, 4, 5, 6. So I know that n equals 6. I also know that if I add up my x minus mu's squared, I get 1750. Scroll up a little bit. There we go. All right, so based on my formula, let's scroll back to the formula real quick. It's basically I take the sum of my x minus mu's squared divided by the number of data points. All right, so let's scroll back. Now notice, because I did the work in the chart, right, my variance, I'm just going to put 1750 divided by 6. And if you do that quick calculation, I get 291.7. Now, why did I stop at 0.7? Standard rounding rule is you round to one more data point, one more place than your data. So my data goes to the ones place. I'm going to round to the tenths place. All right, and if I want the standard deviation, I'm just going to simply square root my variance, and to that I get 17.1. All right, so we know how to do variance and standard deviation for a population. Now we're going to talk about variance and standard deviation for a sample. Essentially is very close to the same formula. So if I say my sample variance, and so my sample variance is done by s squared. We have to denote it with a different letter because it is a slightly different formula. We don't want to mix up the two. All right, it's going to be the sum of, and this is going to look very similar, my data point minus my x bar. X bar again is the mean of your sample. So again, in the numerator looks fairly simple, but then I'm going to do divided by n minus 1. So the number of data points I have minus 1. All right, so, and now my sample standard deviation is again denoted by s, and it's going to be the square root of my variance. Some people write in the whole formula. I think it's a little bit silly, simply because, again, it boils down to being just the square root of your variance. Now, there is an alternate formula for sample variance. All right, and I hate giving multiple formulas. However, in some cases, this alternate formula might be really helpful in and save you some time. So I'm going to offer it up to you as an alternative. All right, so let's see. So I'm just going to say alternate up here. And it's, let's see, I can make that a little smaller so I get a little bit more room. S squared equals my number of data points times the sum of my x squared minus the sum of my x's squared divided by n times n minus 1. Both formulas are going to give you the same answer. Does it matter which one you use? Not to me, it doesn't. So I would say, unless dictated by the directions, you could use either one. All right. So I'm going to do an example, but I'm going to do it with the alternate formula just to show you that it potentially could save you some time and might be a little bit easier in keeping things organized. All right. So let's take a look at the example. I'm going to read the example and then I'm going to list the data. All right. So we're going to find the variance and standard deviation for the amount of European auto sales for a sample of 6 years. Actually, let's write that out. Find the variance and standard deviation for the amount of auto sales for a sample of 6 years shown. All right, and the data is in millions of dollars. So my data is 11.2, 11.9, 12.0, 12.8, 13.4, and 14.3. And again, I'm going to look for pieces of this formula. So let's take a look at the formula I'm using. All right, so first you got to decide which formula you're going to use. If you're going to use the standard formula, then I probably would make a chart. If I'm going to use my alternate, which I've chosen to use here, I want to know my x squareds and I want to know my x's. All right, or the sum of my x's and sum of my x squareds. So you can make a chart if you want to. It's always viable for you. Simply, I would say my data point and my data points squared. All right, so it would be 11.2, 11.9, 12.0, and so on and so forth. All right, I chose to not make a chart and simply say, I want to know the sum of my x's. So that's 11.2. I know some people don't really like the chart thing. I do. So, but you can do it either way. So I wanted you to see that you can work this either way. 13.4, 14.3. All right, and we want to get what that equals. All right, but I also want the sum of my data points squared, which would simply be taking each of your data points right, and squaring them. 13.4 squared plus 14.3. That's a squared. I'll make that a little bit nicer. 14.3 squared. All right, I'm going to pause the video for just a second. I suggest you do the same. And I want you to work out both these. I want you to sum up your data points, and then I want you to sum up each data point squared. All right, and we'll talk about the answers on the back end. All right, so hopefully you summed up your x's. I got 75.6, not 75.9, just kidding about that, 75.6. And then for the sum of my x's squared, I got 958.94. All right, and those are going to be very critical in our formula. So in my formula, I have my number of data points, which would be my n, which would be 6. And then I want to multiply that times 958.94 minus 75.6. 0.6 squared. Divide that by n times n minus 1, which is 5. So again, I'm going to ask you to pause the video, and I want you to run this through the calculator, and let's see if our answers match up. You're certainly also welcome to get your standard deviation as well. So we'll talk about both answers on the back end. All right, hopefully you pause the video and work this through the calculator. I got 1.28 as my variance, and my standard deviation, I got 1.13. And again, same rounding rule applies. If I look at my data goes to the 10th place. So I rounded to the 100th place. All right, so that's a quick run through on variance, standard deviation, and range. There's a lot more practice to be had, and I definitely recommend a lot more practice. Thank you for listening, and I'll see you next time. Great.